Hello there guys, in this video I'm going to talk you through how to find the gradient of a line between 2 points. I'm going to start off by looking at some that have been drawn for us on a grid because I always find a diagram is a useful place to start, but I'm also going to talk at the end of the video about how to find a gradient between 2 coordinates as well. So before we begin, hopefully you are familiar with the word gradient and what it means, and there are 2 methods that you've probably seen before on how to find gradient. Both of these methods are completely fine, so you just choose your favourite, but both methods are actually doing exactly the same thing underneath. So I'm going to do both methods for the first question, and you will see that the same numbers come up in both of them. So the first method is trying to draw a step and then thinking how many across to the left you've gone and how many up. Then using ratio and division to make that 1 across and however many up you need. And that number you end up with there when you're going 1 to the left is your m value or your gradient. And remember, don't be afraid if when you do your division, you end up with a non-integer, okay, like a fraction or a decimal. That's absolutely fine. We often give gradients as fractions because that's easier to work with when you do more advanced maths later on, but decimals are also completely fine. The other way you can think of gradient, and again, this is actually doing the same thing underneath, you'll see the numbers coming out the same, is change in y over change in x. The only thing I would say for this is when the line is going upwards, your change in y is technically positive. When you're going down, your change in y is technically negative. So just as a quick common sense check before you finish, if you do this method, if the line is going upwards left to right, your answer must be positive. If your line is going downwards left to right, your answer must be negative. So do a little check before you actually finish and move on from the question, just to make sure that you've given a sensible answer if you're doing that method. But other than that, either will work for you fine. So we're looking at this line segment here. I'm going to try and move forward so that you can see the coordinates a little bit more easily, but apologies, it's not very easy to see. So the coordinates that I've got here for this question are the coordinates 2, 5 at the bottom, 2, 5 at the bottom, and at the top here we've got 11, 17. I've drawn it on a nice square grid so that we can visually see how many across we're going and how many up. So I'm going to draw on that triangle going across to the left until I'm underneath the other point, and then vertically to meet it. And it might be up or it might be down depending on the question, but in this case it's up. So we've got to go from 2 across to 11 on the x-axis, and because I've done it with squares, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9. But if I didn't have the squares, I could think, well, what's the difference between 2 and 11? And that would be 9. Okay, and then going upwards, again, I can count the squares, or I can think, what is the gap from 5 up to 17, my y values, and that gap is 12. So going back to this way of writing it now, I can say that I'm going 9 across to the left and 12 up. Now to get that across value to 1, I need to divide by 9. And I need to do the same thing on the other side. Now, 12 isn't in the 9 times table, so it's not going to be that easy to divide. So I'm going to write it as a fraction. Remember, you can always write a divided by b as a over b. So 12 divided by 9 can be written as 12 over 9. So for every 1 across I go, I have to go 12 ninths up. So m is going to be 12 ninths. But before I finish and move on from the question, I'm just going to think about simplifying. Both of those numbers divide by 3, so I can change that to 4 over 3, 4 thirds, and I could also write that as 1 1/3. If I wanted to write it as a decimal, I can also write it as 1.3 recurring. If you don't put the recurring dot, it's wrong. If you do put the recurring dot, then it's right. So make sure you remember the recurring dots if you're giving it as decimals, or just stick with fractions, which is what is probably easiest. And when you go on to A-level maths, you'll be wanting to leave it as a fraction anyway for future work. I'm now going to do exactly the same question using this method instead. So if I were doing this method, before I started, I would have a look at the line and think, is it going up or is it going down? This line is clearly going up as we go from left to right, so I know that my answer has to be positive. Okay, I've done that little check first of all. The change in y is this gap here in the y value in the y-axis, or the difference between the y coordinates, the 17 and the 5. That's 12. And the change in x is the change going across, okay, or the difference between the x coordinates, which is 9. So you'll see change in y over change in x still gets us the 12/9. So we still get a fraction out just the same either way, and then we can simplify it to 4/3, 1 1/3, or 1.3 recurring, depending on how you want to leave your answer. Okay, so either method is absolutely fine. If you do this method, don't be afraid to do divisions as fractions. And if you do this method, before you start, think carefully about whether it's positive or negative. Okay, so I've written another question up for you guys. It's a little bit more difficult. If you feel confident with either of these methods, you might want to go ahead and have a go before watching me explain it. But if not, just keep watching now and I'm going to go through it. I think I'm going to write my method down over here. For this one, I'm going to do this method, but you'll find that the fraction I get is exactly the same as what I would get in that, and I will talk about that one as well afterwards. So I've got the coordinate -13.3 and -6, -11. Now, you'll notice here that because this y value is higher than this one, my line is going down. And I would say if you were doing this without a diagram, it's worth at least trying to imagine what it looks like or drawing your own diagram, because a surprising number of people get the direction of the line incorrect, okay, and therefore get the plus or the minus wrong and get their gradient incorrect. So do think about that before you start. Try and imagine where the points are. So the movement across from -13 up to -6 is 7 across, okay, and if you've got it on a perfectly square grid, you can count that. So 7 across, and then from 3 down to -11, well, I had to go 3 down to 0, and then an extra 11 down, so that's 14 down. So it's 7 across, 14 down, 1 across, I can get to by dividing by 7. So I need to divide by 7 on the other side as well and get 2 down. So my gradient, my m value, it's 2 down, or in other words, -2 up. So my gradient is -2. Okay. If you want to do this method instead, first of all, looking at our line, it's going down, so we know our gradient has to come out as a minus number. Okay. Its change in y is technically negative because it's going down, so -14, and change in x is 7. -14 divided by 7 is -2. Okay, so we get that same answer either method. Okay, guys, so here are 2 more questions that I'd like you to have a go at. So we've got -11.11 and 9.16 and the gradient between them. And we've also got -4, -15 and 4.5 and the gradient between them. So pause the video now and then play when you're done, and I'll talk through the process. Okay, so for the top one, I'm going to do the across and up method. And then for the second one, I'm going to do change in y over change in x method. So from -11 over to 9, I've got to go across a very long way. I've got to go across 20. So it's 20 across to the left. And when I go 20 across to the left, I then have to go up from 11 to 16, which is a gap of 5. For gradient, I need my left across value to be 1. So I need it to be 1 across. To do that, I'm dividing by 20. So I need to do the same thing over here. So it's 5 divided by 20 up, or 5 over 20. So my gradient is just 5 over 20. Both of those values can be divided by 5 to get 1 over 4 or 0.25, but I'd probably write it as 1/4, okay, to have it as a fraction. For the orange one, I'm going to do change in y over change in x. So first of all, looking at that line, it's clearly going up, so my gradient is going to be a positive number. My change in y, if I look at my y coordinates, I'm going from -15 all the way up to 5. So I'm going 20 up. So I've got a 20 on the top. My change in x values, I'm going from -4 up to 4. So the gap between -4 and 4 is 8. So I've got 20 over 8. And I can now simplify that. I can go down to 10 over 4 or 5 over 2, which is 2.5, or 2.5. Okay, again, I'll probably give it as 2.5 or 5/2, depending on what I was about to do next. Okay, so now I've gone through some examples with diagrams. I'm going to talk you through a question that doesn't have a diagram given. Okay, and realistically, if we had this in GCSE or A level, we also would not have square paper on us in order to be able to make our lives easier. So we're going to think about the gradient between 8.3 and 12 minus 6. What we could do is draw ourselves a sketch. Okay, now it's not going to be perfectly drawn. It's not going to allow us to count squares, but what it will do is allow us to visualize whether the line's going up or down, and depending on how accurately you draw your sketch, roughly how steep it's going to be. So 8.3 is along 8 and then up less, because 3 is smaller than 8. So 8.3 is going to be about there. 12 minus 6 is going to be further along, because 12 is further along than 8, and it's going to be 6 down. So it's going to be down here somewhere. Sorry, I'm just going to extend my axis. You don't have to draw things to scale, so you can normally just fit them on whatever you've drawn. I went a little bit too far there. So this is what my line looks like from 8.3 to 12 minus 6. So I know that my line is going downward, so my gradient is negative. And I now, if I want to, can put my 8, my 3, my 12, and my minus 6 on. You don't have to do this. It depends on how easy you find it to visualize. But now you've got the two numbers you need for your change in x and your two numbers you need for your change in y. So gradient is change in y over change in x. So I'm going from 3 down to minus 6. I'm going down 9. So my change in y is negative. And my change in x from 8 up to 12 is 4. So I've got minus 9 over 4, which is the same as minus 2.25, or minus 2.25 for my gradient. Okay, you don't have to draw the diagram. There is an alternative way that I'm going to go through now as well. Okay, so this is the formula for the gradient between 2 points. You do not have to rely on using this. It's doing change in y over change in x. But if you're someone who finds this a little bit nerve-wracking, a little bit too much, then stick with one of the previous two methods we've done, because you can logic your way there using that. You'll notice that the y's and the x's here have a little subscript number written next to them, either a 2 or a 1. That little subscript number is just telling you which coordinate the number has been taken from, so either the first coordinate or the second coordinate. I would suggest, particularly while you're getting used to this, is before you put the numbers in, label which one is x1 and x2, and which one's a y1 and y2. And remember that a coordinate has an x and a y, so you don't make these two x's. Okay, you've got an x and a y. So this one is going to be my x1, the 8. This one is going to be my y1. Okay, and over here, this is my second coordinate, so my x2 and my y2. So your first coordinate have 1s in them, and your second coordinate have 2s in them. It doesn't matter if you actually do them the other way around, it still will work out. It's just you'll have minus numbers to deal with. Okay, so as soon as you've identified what those values are, you can just put them into the sum and it will get you the gradient. And this is the same question as the one I just did a minute ago. So we're expecting our answer to be minus 9/4 or minus 2.25. Okay, so if I put in my y2, my minus 6, and my y1, which is 3, and then my x2, which is 12, and my x1, which is 8, I then just have to work out the top, work out the bottom, and do the division. You are going to have more negative number work if you do this method, so you're just going to have to accept that and be careful with it. So minus 6 take away 3 gets us to minus 9, and 12 take away 8 gets us to 4. So we've got our minus 9/4, which is the same as 2.25 with a little minus in front of it, minus 2.25. Okay, I'm just going to show you for interest that it still works if you put both sets of numbers in the other way round. So in order to do this, I need to change the names of all these coordinates. So I'm going to change these to x2 and y2, and these to x1 and y1, and you'll see it still works. So m is y2 minus y1 over x2 minus x1. So if I put my 3 in here, minus my minus 6, make sure you've got both minus signs going in there because you're taking minus 6, over 8 minus 12. 3 minus minus 6, well, when you take a negative, you add, so that's 9. And 8 take away 12 is negative 4. 9 divided by minus 4, positive divided by negative is a negative, so we end up with minus 2 1/4. I just wanted to show you that because you'll see that it does work, but if you rely completely on this method, you can end up really getting caught up in lots and lots of negative number work. Okay, it's fine and it will work, but if you are going to persevere with this method, my 2 pieces of advice are: make sure you think carefully about your labeling, and if you find that you don't consistently get these right every time, it's worth just taking a moment to write them down with the labels, and then just be really careful working through your negative number work. If you can, visualize or do a diagram of where those points are in relation to each other, so you know whether you're expecting upwards or downwards, a positive or a negative gradient, okay, because it just makes things much, much easier. What I'm going to do now is I'm going to give you a couple more sets of coordinates, and then you can use whatever method you prefer in order to try and find the gradient of them. Okay, so here are 3 questions. Pause the video now and see if you can find the gradient between those points. And if you would like to draw a diagram, then feel free. I would try and do one that doesn't have the square grid on behind it, so you can't just count the squares, you have to think about the actual numbers. Okay, I'm going to go through the process for these now. I'm going to do one method for each of them, and I might need another board in a minute to give myself room. So first of all, I'm going to think about the journey across an up or down. So to get from 5 to 7, I have to go 2 across, okay, and I'm travelling from left to right when I go from this one to this one. So then I've got to think about going from 8 to 4 on the y-axis. 8 is bigger than 4, so I'm going down. So it's 2 down, or you can write that as minus 2 up. Sorry, it's 4 down, isn't it? From 8 to 4 is 4 down. So I'm going to go 1 across by dividing by 2. 4 divided by 2 is 2. So my gradient is minus 2. Okay, the next one I'm going to do change in y over change in x. So first of all, I'm thinking about going from this coordinate to this coordinate. So to go from 2 down to negative 16, I'm going down 18. So it's minus 18. And to go from minus 3 to minus 2, I'm going 1 across. So my gradient is negative 18. Okay. For the last one, I'm going to do the y2 minus y1 over x2 minus x1, which is actually the same as this, but just with a little bit more written out. Okay, so before I start using the formula, I'm just going to say that my 6, 2 is my first coordinate. So that's my x1 and my y1, and my 1, 8 is my x2 and my y2. Doesn't matter which way round you do it, it will work either way. So now my gradient is y2 minus y1 over x2 minus x1. So y2 is 8, y1 is 2, x2 is 1, and x1 is 6. 8 minus 2 is 6. 1 take away 6 is minus 5. 6 divided by minus 5 is minus 6 fifths. Got them all way up there. Which is the same as minus 1 1/5 or minus 1.2. Okay, so any of those ways of giving it is absolutely fine. Okay, just one thing to mention, if you actually plot these, you'll notice that this coordinate is to the left of this one. So if you had gone for an alternative method, you might have wanted to think about going from this one to this one instead, because 1, 8 is there, 6, 2 is there. So you could have gone from there to there and thought about 5 across, and then from 8 to 2 is 6 down. So if you are using that method, just think before you start which coordinate is where in relation to each other, which is why the diagram might help you out.